Hello everyone, welcome to 𝗓𝗃𝗧. So in this lecture, I am going to explain how you can input and size specific response spectra in ETABS. So for that, what I have done, as I don't have any site specific spectra, I have created the response spectra data, time period versus SAYG and AH as per the codal provision for hard rock soil. So if you see that for hard rock soil, this is the provisions. So we have the time periods and the SAYG values. So these are basically the SAYG values that we should take, and this is the time period range. Okay, so based on this, what I have done, I have created a Excel sheet. So you can see these are the time periods, and I have taken interval of 0.5 seconds, and then I have calculated the SAYG. What I have done, I have just given this you can say these ranges I have defined here in the Excel. You can see if A3 means the time period is less than 0.1 second. So in this case, it will be 1 plus 15 into time period. So this I have done. Then again, if A3 is, you can say this the time period is greater than, you can say 1 second. And if it is less than or equal to 4 second, though it is not given equal to, I have taken equal to. So less than or equal to 4, you can say 4 second. In that case, 0.4 second. In that case, 2.5 should be taken. And if it is greater than 4 second and greater than 0.4 second and less than 4 second, so in that case, 1 by time period will be taken. Otherwise, in every other case, that means in case of the time period greater than 4 second, 2.5 will be taken. So you can see here that I have made a range of time period up to 8 seconds, and after 4 seconds, here you can see from 4 seconds all the values are taken as 2.5. and then what I have done, I have calculated the AH using the formula, which is Z by 2 I by R S by G. So Z by 2 into I by R multiplied by S by G. So for every corresponding time period, the corresponding S by G value we have, and the corresponding AH value we have calculated. So to calculate the AH, what I have done, I have just given these inputs here: the zone factor, importance factor, and response reduction factor. And similarly, Z by 2 I by R and S by G, the corresponding S by G value I have taken, and I have created this AH. So why I have created this AH? Basically, in ETABS, in the response spectrum function or any function you define. So in the response spectrum function, what it does, it creates what is the default definition we have for response spectrum definition. ETABS does time period versus age curve, and then what you have to do, you have to multiply this with my acceleration due to gravity, and this value we give in the load case. Okay, this value we give in the load case. Now if you do time period versus SA by G, suppose you are doing time period versus SA by G curve, you are defining in the function. Okay, defining in the function. In that case, in the load case, the scale factor, what you have to do, the scale factor will be then AH multiplied by my acceleration due to gravity. So to reduce our confusion or to reduce our job, what I have done, instead of creating T versus SA by G curve, I have created T versus AH curve. So this is time period versus AH curve. Okay, so for every corresponding time period, we have got the AH and we have got the curve here. Okay, so this is actually the design response spectra for hard rock soil as per IS 1893. Now, in case you have the site specific spectra given by your client, so it will be in the same form. Maybe the spectral shape will be different, or maybe the same. So now if we have this kind of data, that time period versus SA by G or time period versus AH, if it is not AH, SA by G, you can convert it into AH if you know the zone factor and importance factor and response reduction factor. So you can easily convert it into time period versus AH. Okay, so these information you will have with you. Okay, so what I will be doing, I will be creating a time period versus AH curve in user defined function in ETABS, and in the scale factor we will give only the G value in the current unit, which is 9806.65 mm per second square. Okay, fine, or 9.81 meter per second square. So I will go to ETABS and I will go to define. Suppose, see, this curve I have, ETABS is capable of you can say create the definition of the design response spectra as per IS 1893. Okay, but as I don't have any site specific spectral data, so that's why I have taken the same, just to show you how you can define a site specific spectra, okay, or a user defined spectra. So now the process is, if you go to ETABS and define function response spectra, I will take the user, you can hear user function, then I'll click on add new function. Now you can see what you have to do, all these time periods and the spectral acceleration one by one you have to add. So if you see here, first one is 0, and for that the AH value is 0.024. so suppose I am putting this 0, and for this it is 0.024. add one more, you have to add, sorry, so you can see 0.05, and for this 0.042. so 0.05, for this 0.042. add. Now you can think that I have added 2 data only, and to add all these datas, okay, up to 8 seconds I have with 0.5 interval, how much effort it needs, one by one you have to add, right? So, and this is also, remember, the spectra I am adding, it is for 5% damping, okay. So obviously you will have, if you have site specific spectra, there will be spectras for 2% damping, 5% damping, like that. So whichever is required for you, you have to define here, and you have to give the damping ratio as accordingly, okay. So the design spectra we have in IS 1893, it is for 5% damping only, so I have taken the default value of 5%. So now my concern is how to put this particular information here one by one, because it will take a lot of time, or maybe in between you may do mistake also, right? So in that case, what I will do, initially I will define a function like this. Suppose it is site specific RS response vector, okay. So you have created one, and you have added any random 2 values here, and click on OK. So we have this definition with us, and click on OK. Then save it. Okay, just save it and close this model. Fine. Now, if you go to the folder where you have saved the model, you will find this file, this text file in the $et file, or you can say we call it as E2K file also. So this $et file, or set file also we call, whatever you call it, just see this file type, okay, this file type you need to find. So this is an text file, you have to open this text file. So just open this text file, let me make it bigger, and if you go down, you will see that there will be a function defined. So just you can search Control F, and you can search function. You can see functions, there are different functions, time history functions, and the default functions defined. Other than this, the site specific RS function is here. You can see the damping ratio 5%, spectra type is user function, and here if you see the time interval, sorry, Control Z, after time interval, how the pattern you have to follow. So the pattern is time period, then 2 spaces, the the AH value, again 2 spaces, again the time period, the next time period, then AH, like that. So time period, 2 space, SAG, again 2 space, again time period. So this pattern we have to create, okay, this pattern we have to create. Now let's see how we can create this pattern. So I'll go to this Excel sheet, I'll take another sheet, so it is sheet 3. Here I will use a very useful command, which is concatenate. So con, you can see this concatenate is there, double click here, bracket, I'll go to the next the previous you can say page or previous sheet, I need the time period first, okay, comma, then I need two space. So for giving two space, you have to give inverted comma, double space, and inverted comma. So you can see here I have inverted comma, one space, second space, another inverted comma, again comma. So it will create a space in between, two space in between, and then you need this AH. Okay, you close the folder, sorry, close the parenthesis and click on enter. Okay, so you got one. Similarly, you create for all other like this. Okay, I don't know up to what value it is there. Let me see. 8 seconds means up to 163. So okay, I'll go up to 163. After that there will be nothing, right? I went up to 161 only. Oh, okay, there is, if you see here, there is two spaces, so that's why here it is 161. Okay, fine. So up to 161 we have created this. Now what I will do, let me change the format. I'll go to format cell, number up to 3 decimal points only I will take. Fine. Okay, so now we have created this. Now we have to create another concatenate between these values. So how we'll do, I'll take this cell, I'll click on equal to, again concatenate, I'll take this. So this value, comma, we need double space, so I'll give double inverted, okay, two space, I'll give comma, and the second one, I'll close the parenthesis, click on enter. So you can see here what we have got, this add this. Okay, fine. So I will press enter. Now if I just drag it below up to here, if I do, what will happen? Okay, no, sorry. So first of all, what I will do, Control Z I will do, I got this. Okay, I got this. Now what I will do, here I will create another one, equal to concatenate, okay. Now I will take this above one, previous one, this one, let me do, actually I did it a wrong way. What I will do, I will give equal to this, then equal to this, the previous one, let me give concatenate, CONCATE, concatenate, the previous one, the previous cell, comma, double inverted, between I need two space, okay, comma, the next one here, control, close the parenthesis, I click enter. Now you can see how it has created. First it has given 0 space 0.024, then it has created space this one. Okay, now if I just drag it to the next, what it will do, it will take this one first, then the next one, then if I drag again the next one, it will do the previous one first, then the next one. Like that it is creating the time period space SFIG, time period space SFIG data. Okay, so I hope you understood. First one I have taken the same, the second one I have taken this previous one, concatenate, you can see concatenate, this previous one, comma, parenthesis, sorry, double inverted, then 2 space, another double inverted, comma, then I have taken this second one from here. Okay, so now if I just drag this up to here, you can see all this information will be created. So what we have to do, as the previous one will be taken with the next one, so what I will do, I need to add another one here. So what it will do, it will take this one. I think it is not needed actually. Let me see if it is taken, this one plus that one. Okay, it is taken, so this one is not needed. Fine. Okay, so here itself we are getting the previous one with the next one. Fine. Okay, got it. So now what we have done, we have created the format in the we have created the time period versus SFIG or AH format with the format of text format of ETABS. So I'll just Control C, copy it. I'll go to the text file. Okay, it is a bit complex, but you have to understand what is the format of this. I'll delete this and I'll paste it here, Control V. Okay, then you have to see this comma is here, you just take the comma here. Okay, so it starts from here and it ends here. Okay, fine. Okay, so now what I will do, I will see there are some very high values, like what the Excel has done. It has taken many numbers. I will just delete this. What I will do, one thing I will do, I will go to my Excel file. Okay, I will take this format cell numbers. I will take up to 3 numbers only, and then I will copy this, Control C. I'll go to text, I'll give double inverted comma, Control V, and I'll close it here with double inverted comma. Okay, I'll save this, I'll close it. Okay, so the Excel, you can see how you need to create the previous one adding with the next one. Okay, so now I will go to my ETABS. So I will just open the ETABS from here. Then I'll go to import, file, import, ETABS E2K text files. I'll select the text file where it is, I can say saved. I'll click on open. So it is open. Now if you go to define functions, response spectra, this function if you modify, you can see all these values are kept here. So you can see that at last we have for 8 seconds it is 6 power 10 6 into 10 power minus 3. E-03 means 10 power minus 3, right? So 6 into 10 power minus 3, that means 0.006, right? 10 power minus 3, 6 into 10 power minus 3 means 0.006, 1 to 3. Okay, for 8 seconds. And for the first one, for 0 second it is 0.024, for 0.05 it is 0.042. So if I go to my Excel sheet, if I go to this, you can see for 0 it is 0.024, for 0.05 it is 0.042, and at the end for 8 second it is 0.006, correct? So the similar one we have defined here very easily, one by one. You didn't have to put actually, and here you go, you got the time period versus AH curve. Okay, if you now click on OK. Okay, now what you have to do, in the definition, define load cases. In the definition, the initial response scale factor you have to put, it is the 9806.65, which is the current unit. If you see, it is in mm per second square acceleration. So this acceleration due to gravity, the value we are putting here, because the AH already multiplied with the SFIG in the response spectrum function itself, correct? Okay, so I hope you understood how an user defined, or you can say how a site specific response spectra can be imported to ETABS using the text file. Okay, so you just have to do some work in the Excel. You have to put this time period and age or SAYG, whatever it is, and then you have to create this format. So the format is nothing but time period, then space, then again space, then we have age or SAYG, whatever you want. So this is the format actually you need to create. Okay, so what we did first, let me just give you an overview again. What we did first, for each time period versus age, we have created separate cases here like this. Let me just format this, the numbers up to 3. Okay, fine. So every case we have created. Then in the next case, what we have done, we have taken the first one. Here in the second case, what we have done, we have created the previous one, concatenate this previous one, then comma, then in inverted we have 2 space. That means if you need to have a space or any text file, you need to give this double inverted. This is a basic Excel we all know. Okay, and then comma, then the second value. So 2 times we are using this concatenate. First to add the time period and SAYG for each case, and then to combine this all together, right? So the first case from here, so what it is doing in the second case, what it is doing, it is taking, you can say, the above one where these 2 were added, and then the third one from here. In the next case, it is taken the above one where these 3 were added, okay, and then the fourth one. Like this it is adding, and at the end, as if you see here, the previous one where all these are added with the next one. Okay, so you just have to use this concatenate command to create this text format, and then you put it in the set file, or you can say in the E2K file in the correct place as I showed, and then if you import it, you will see that the function is defined properly here. Okay, so this way you can define a site specific response spectra in user defined way in the ETABS actually. Okay, so I hope you'll like this video. I will create more such tips and tricks video in future. If you have any doubt, you can always write me in the chat box, or if you have any suggestion, please do let me know in the comment, so that I can implement those ideas in my next videos. Thank you, and see you in the next video.